Hello YouTube, my name is Logical Unit and I am recording my very first content video about running Linux LMDS on a Raspberry Pi. This is a project that combines several Docker containers to make a complete multimedia pipeline. It allows you to download videos and movies, TV shows through BitTorrent. And then it hosts them so you can stream them to your front end. So what I've got with me at the moment is my Raspberry Pi 4 and a great little kit that I really like. It's called the RPi Quad SATA Hat. Now I'm pretty sure the RPi is a Chinese clone of the Raspberry Pi, but it's completely compatible with the Raspberry Pi. What it does is it takes a Raspberry Pi 4 and it adds up to 4 solid-state drives as external storage over the USB 3 bus. It's a terrific little kit. I got mine, this is it here, there's a black version now, mine is white. And I was able to pick this up for $99 US. And it's a great little device. I've been using it for a while now. You know, the Raspberry Pi is a great platform for education and hobbying and tinkering and various other things, but it doesn't come with a whole lot of storage. It has a micro SD card in the Raspberry Pi 4 has a micro SD card, and that, you know, I've got a 16 gig card, and that's really not enough to hold lots of content. So what we do, we add up to 4 SSDs over the USB 3 bus, and that gives us plenty of storage. I did this project because I had some SSDs lying around. I had, you know, three SSDs not doing anything, so I put them into this kit, and now I've got lots of things I can do with it. So LMDS, LMDS, the Linux Media Delivery System. It's a project that combines a number of Docker containers to create this pipeline. So the pipeline is, you know, identify a show or a movie you'd like to watch, download it, and then stream it, and we'll have nice metadata and organized files, so it's easy to watch and enjoy. Now, it uses Docker containers. This is a really great exercise in Docker containers. What are Docker containers? Why would you use them? It's basically a way of packaging a product together into a single sort of unit that can be easily updated. Why you would do this, so let me go back a step. So you could do, for example, a Nextcloud Docker container. Nextcloud is a NAS cloud file storage solution, and it's quite good, but if you did the native install, you'd be mucking around with web servers and various other things to get it working. The reason you would use this, the LMDS, is because it makes it easier to combine multiple servers, multiple products, multiple packages into one cohesive system. So if you just wanted a Nextcloud server, do the native install. Just use apt-get to install Nextcloud like you normally would. If you just wanted a Pi-hole, just install that on using the native install like you normally would. But this pipeline is using a number of different things to work together. So Sonarr and Radarr, these are your content managers. This is what allows you to search for movies and TV shows. It grabs from a database. It adds artwork and metadata and ratings and all that sort of useful stuff. Deluge is the BitTorrent client we'll be using to do this. Jellyfin is a great open source media server. We'll be doing this through a VPN to obfuscate all of our traffic. So if you just want your server to do one, maybe two specific things, just go with the native install. If you're setting up multiple products, multiple servers, particularly that will be interacting over a web interface, using Docker can make it a little bit easier. That said, the entry point to Docker is a little bit high. You have to configure a lot of things, and it's not always immediately obvious how to do that. There's a product called Docker Compose that allows you to put that configuration into YAML, which is YAML ain't markup language. It's basically just a format for key value pairs. Helps us define variables easily. But the main purpose of this project is to help us build a stack. What's a stack? A stack is configuration for multiple containers that will be working together. So what I've got is my Raspberry Pi 4. I've installed Open Media Vault. So step one is to assemble the NAS, and I won't go over that. It's been done before, but you'll want to use the Raspberry Pi OS application. I'll have to check what it's called, but you want to install the 32-bit Lite version onto your memory card. We don't want 64-bit, and Lite just means we'll be working as purely as a server. We won't have any graphical output connected to the Pi. We'll be interacting it through the command line. So I've logged into it here. So I've got Open Media Vault. Now, Open Media Vault is basically a web-based administration platform. You can install it from one command on the Pi, and it helps us do things like manage our disks, create file systems, configure our network, high-level system administration stuff. So you can see here are the three SSDs I had lying around. One of them is 240, and the other two are about 120 gigs. So to do this project, it's a great Raspberry Pi project. It's for people who want to download videos, TV shows, movies. This is totally piracy. I expect to get demonetized, but the point is actually doing the project, not pirating the content. The point is to get it up and running. So what we'll be doing is we'll be configuring the Docker containers, getting them all set up step by step, interacting, working with each other, and then hopefully we'll have a nice web interface where we can just search for what we want, download it, and then play it on our front end. I've got Google TV. Google TV is fantastic. You can just install the Jellyfin client on Google TV, and you'll have a nice front end. So the back end, the thing that downloads and hosts the media, is the Raspberry Pi, and then your Google TV can watch it. So I'll clear this. So I've just logged into my Pi. What I have done, so a couple of commands that are helpful. ls USB, this shows us our USB devices, and these two here, these Western Digital JMS 56X ones, those are the controllers that add solid state drives to the Pi. Another useful command is lsblk. That shows us what we've got mounted. Now, this mount point here, you can see it's a bit of a mouthful, but this is just how Open Media Vault works. I've used Open Media Vault to create my file systems for each of these devices, and I'm not doing anything cunning with the partitions or the file systems. It's just each SSD gets a single partition that spans the entire drive. We've formatted it in ext4, which is fairly standard for Linux. But going back to this one for a moment, what I have done is I've created a symlink in my home directory to these mount points, and that just makes life a lot easier when we're working with the command line and when we want to access the drives or the files on those drives. So SDA goes to the first mount point, SDB and SDC. So I can just go CD SDA from the home drive, and boom, that's the contents of SSD number one. Go back, CD SDB, and then CD SDC. And as you can see, they've all been formatted. They're all empty. All I've done so far is install Open Media Vault and then use that to set up my file systems. These symlinks are soft links. So if you want to set them up, you'll have to do sudo ln-s, and the -s is important. That defines a soft link, which enables us to link to another file system, because this path here, the home path, that's on the micro SD card. These are different file systems on SSDs. So we need the -s command. If you haven't used symlinks before, I might just give you the command. I think it's, well, I can never remember if it's the name of the link first or the target first. Let's do Linux ln command. So this video, I'm going to be working this out as I go. I've done this before, but the purpose of this video for me is to do one. To get OBS set up and working, to make some content, and to make a start. Okay, symbolic, yeah. So it's the target first, and then name of the link. Cool. And you can do sudo, which is shut up and do the operation. Link soft path to the mount point, and then name of the link. So that's just a convenience thing that'll make it easier to work with these external SSDs. So what we need to do first with the LMDS is clone it from GitHub. Now, as of the last time So first thing we'll need to do is install Git. Git is a tool for managing source code. And put it this way, I think this tutorial, this video I'm making, it's intended for people who know a little bit about Linux, who know a little bit about Raspberry Pi, who want to learn about Docker, who want to tinker around with the command line, become a bit more familiar with networking, Open Media Vault. It's a great little hobby, educational hobby project. The point isn't the piracy, the point is to get it working. So what we want to do is clone the repository, and I think I've already done that. Yep. So LMDS, this is the folder we're going to be working in. Now, let me explain this to you. This is quite handy to go through. So deploy.shell or deploy.sh, that's the main script file, but we've got a few folders here, and it's worth going through these. Downloads is so go back a step. When you create a BitTorrent container, you'll generally need to specify a target for the downloads. And by default, all the containers included with the LMDS project are configured to go to this folder. But this folder, as it stands, lives on the micro SD card, that 16 gig SD card, and that won't be big enough for lots of downloads. So what I am going to do is redirect it to one of my external SSDs. So I've got 3 to choose from. I think I'll just go with C, that's fine. So basically this script, it'll help us build the stack. That's a YAML file with a bunch of configuration for all these containers, and that configuration is set up to use these folders. So what I'm going to do is I am going to rmdir downloads. So I've deleted the downloads folder, and instead I'm going to make a link. I'm going to go sudo ln-s, and I'm going to use that convenience link I made earlier, which is SDC. So this one here, it points to the file system on that third drive, and this link itself lives in the root directory for this user. So we'll do that. So now our downloads folder is pointing to this path, which is itself a symlink, this last bit here. So if we cd downloads, we now find ourselves on this drive here, right? So that means all of our containers that are doing any torrenting will use this drive. So something else I want to set up before we get going. Media. We've got movies and TV shows. And I'm going to do a similar thing. I think I'll use the big drive for those two. Yeah, SDA. Actually, I'll create a subfolder for it on that drive. So if I go cd sdc, whoop, go to home, cd sdc, I think, I'll do it. Also, mkdir downloads. Shut up and do the operation. Yeah. So all I've done is create a file system. Sorry, create a folder called downloads in the root of that file system, and that just keeps things a bit better organized. If I ever want to use something else on SDC, it'll be cleaner. So the path is ~/sdc/downloads, and the link is downloads. Right, cool. So when we go to cd downloads, we should have a nice empty directory. Great. I'm going to go to cd sda, biggest hard drive, the 220 gig one, or 240 gig one, and sudo mkdir movies, sudo mkdir TV shows. There we go. So I now have a folder on that drive for those two. We'll go back to cd LMDS. And LMDS lives in that root directory. That's where the project intends it to go. It'll be created when you clone the Git repository. So cd, whoop, LMDS, cd media. So we basically just want to point these two directories to the directories we've created on the hard disk. So rmdir move. So what we've done is basically this project, LMDS, it's designed to run on Raspberry Pi. But our Raspberry Pi, this NAS kit that we bought, has its SSDs connected to the USB 3 bus. That's how they're set up. So what I've done is take some time to tell the project to use those SSDs that we've connected, right? So if we go to LMDS, the downloads will be going to SDC. The movies and TV shows will be going to SDA, and we've got SDB for other things. So I'm going to pause it there, and we'll come back to this in just a moment.